The number of generations n of a population of bacteria cells is given by n equals 3.3 times the log of lowercase b divided by capital B, where capital B is the number of bacteria cells at the beginning of a time interval and lowercase b is the number at the end of the time interval. A. Find the number of generations in a bacteria population that increases from 100 to 10 million cells. B. Find the number of bacteria at the end of the time interval if the number at the beginning is 100 and there are 9.9 generations. So A, we'll start with the equation n equals 3.3 times the log of little b over capital B. And we'll substitute in the variables that we know. We're looking for the number of generations, so we're looking for n times 3 equals 3.3 log base 10 increases from 100 to 10 million. So little b is the larger amount we're increasing. This is the end of the time interval, so little b is 10 million. And capital B is the beginning of the time interval, so that would be 100. And we can simplify this fraction. N is equal to 3.3 times the log of 10 million divided by 100 is 100,000. And when we number crunch on our calculator, 3.3 times the log of 100,000 is equal to 16.5. So N is equal to 16.5 generations. Part B, find the number of bacteria at the end of the time interval if the number at the beginning is 100 and there are 9.9 generations. So again, we'll start with n equals 3.3 times the log of lowercase b over capital B. And again, we'll substitute in the values that we know. Find the bacteria at the end of the time interval. So that's lowercase b. We're looking for lowercase b when capital B is 100 and n is 9.9. So we have 9.9 equals 3.3 times the log of little b over capital B, which is 100. So we're solving this for lowercase b. We'll divide both sides by 3.3. giving us 3 equals log of lowercase b over 100. And we'll go ahead and convert this to an exponential equation. The base is 10, so 10 cubed, 10 to the third power equals b over 100. And 10 to the third power is 1,000. We have 1,000 equals b over 100. We cross multiply, and therefore b equals 100,000 bacteria. So there is the number of bacteria at the end of the interval, 100,000.